Hello viewers, today we are going to talk about the ciphers. We are living in the information age. We need to keep information about every aspect of our life. In other words, information is an asset that has a value like any other asset. As an asset, information need to be secured from attacks. To be secured, information need to be hidden from unauthorized access, that is, confidentiality is to be maintained. It is to be protected from an unauthorized change, that is, integrity is to be maintained, and the information should be available to authorized entity when it is needed, that is, availability should be maintained. In order to secure the information, two general techniques are there. One is cryptography and other is steganography. The cryptography is a technique of encrypting and decryption of message using secret keys, and steganography is a technique in which the message is concealed by covering it with something, for example, covering with an image. The encryption and decryption of the message can be done by using any of the three methods, that is, symmetric key cipherments, asymmetric key encipherment and hashing. Symmetric key encipherment uses same secret key to encrypt and decrypt the message, while in asymmetric key encipherment, public key and private key concept is used for encryption and decryption of the message. In hashing, fixed length message digest is created out of variable length message. In this lecture, we will discuss the various methods of generating ciphers from the plain text. Let us start with the symmetric cipher model. Symmetric encryption scheme has 5 ingredients as shown in figure. They are plain text, encryption algorithm, secret key, ciphertext and decryption algorithm. Plain text is the original intelligible or readable message or data that is fed into the algorithm as input. Encryption algorithm is the algorithm that perform various substitution and transformations on the plain text. Secret key is also input to the encryption algorithm. The key is a value independent of the plain text and of the algorithm. The algorithm will produce a different output depending upon the specific key being used at the time. The exact substitution and the transformations performed by the algorithm depend on the key. Ciphertext is a scrambled message produced as output. It depends on the plain text and the secret key. For a given message, two different keys will produce two different ciphertexts. The ciphertext is an apparently random stream of data and as it stands is unintelligible. Decryption algorithm. This is essentially the encryption algorithm run in reverse. It takes the ciphertext and the secret key and produces the original plain text. In the figure, we have shown the simplified model of conventional encryption. Before moving on, we should understand what is the crypto systems. The crypto system is a whole procedure or the system which converts the plain text into the ciphertext at the source and converts the ciphertext into the plain text at the receiver. Cryptographic systems are characterized along 3 independent dimensions. The first is the type of operation used for transforming plain text to the ciphertext. All encryption algorithms are based on 2 general principles. The first is substitution, in which each element in the plain text, bit, letters, group of bits or the letters is mapped into another element, and the other principle is the transposition, in which elements in the plain text are rearranged. The fundamental requirement is that no information be lost. The most of the practical systems are referred to as the product systems, which involve multiple stages of the substitutions and the transpositions. The second dimension is the number of keys used. If both sender and the receiver use the same key, the system is referred to as symmetric key crypto system, as we discussed earlier. and if the sender and receiver uses different keys, the system is referred to as asymmetric key cryptosystems. The third and the last dimension is the way in which the plain text is processed. A block cipher processes the input one block of element at a time, producing an output block for each input block. A stream cipher processes the input element continuously, producing output one element at a time as it goes along. But still, the crypto system to work properly, there are two requirements. One is we need a strong encryption algorithm, which should be such that if an opponent who knows the algorithm and has access to one or more ciphers text should be unable to decipher the ciphertext or figure out the key. And the second requirement is the sender and receiver must have obtained copies of secret key in a secure fashion and must keep the key secure. We assume that it is impractical to decrypt a message on the basis of ciphertext plus knowledge of encryption or decryption algorithm. In other words, we do not need to keep the algorithm secret, we need to keep only the key secret. Now, let us start with some classical encryption techniques based on substitution. A substitution technique is one where letters of plain text are replaced by other letters, numbers or symbols. If plain text is a bit pattern, then the cipher is another bit pattern of the same length. We discussed some substitution technique that had been used in early times. We follow the convention of using small case letters for plain text and the uppercase letter for the ciphertext. We are starting with the monoalphabetic ciphers, the one in which only one character or alphabet is replaced or changed. The first monoalphabetic cipher is the Caesar cipher. This is a simple technique used by Julius Caesar. The Caesar cipher involves replacing each letter of the alphabet with the letter standing n places further down the alphabet. For example, the plain text is meet me after a toga party. If we move the letters 3 places down the alphabet, we get the cipher PHHW, PHDIW, HU, WKH, WR, JD and SDU, WB. This is by moving the 3 letters down the alphabets. The alphabet set is wrapped around, that is A follows Z. In this example, we have taken n is equals to 3, that is we have moved 3 places down the alphabets. If the numbers 0 to 25 are assigned to alphabet, then the encryption or the ciphertext C is obtained by the formula P plus 3 mod 26, where P is a plain text character. A shift of k characters in the general Caesar algorithm, encryption and decryption formulas are given as C is equals to P plus k mod 26, where k is equals to 1 to 25. And the decryption is obtained by plain text is obtained by C minus k mod 26. If it is known that Caesar cipher technique is used, the cryptanalytic attack is easy. Attacker can try values 1 to 25 for k systematically, and whichever k gives intelligible text, that k is the key used. Let us take the ciphertext we have obtained earlier. The cipher is the PHHW, PHDIW, HU, WKH, WR, JD, SDU, WB. Now, using k equals to 1 and generating the plain text does not give the intelligible plain text. Similarly, using k equals to 2 and generating the plain text does not give the intelligible plain text. But using k equals to 3 and generating the plain text, meet me after a toga party, which is the original plain text and is the intelligible text. Thus, here with 3 attempts, intelligible text is exposed. No other k gives intelligible text. This is how the Caesar cipher can be attacked. Next, the monoalphabetic cipher is the affine cipher. We can combine the additive and the multiplicative ciphers to get what is called the affine cipher. Additive cipher is a Caesar cipher in which the key and the plain text alphabet is added and the modulo operation is done to get the ciphertext as discussed in the previous section. Multiplicative cipher is the encryption algorithm in which multiplication of plain text with the key is done to get the ciphertext, and the decryption algorithm divides the ciphertext with the key to get the plain text. In Affine cipher, two keys are used. The first key is used with the multiplicative cipher and the second key is used with the additive cipher. The figure shows that the Affine cipher is actually two ciphers, one applied after the other. The concept of Affine cipher is shown in figure. Here the plain text is the input which is acted upon by the first key K1. With this key K1, multiplicative cipher is generated as P multiplied by K1 mod 26, and the output thus generated, say T, is then acted upon by the key K2, which performs the additive cipher as T plus K2 mod 26. The cipher thus generated, say C, is said to be as Affine cipher. At the receiver end, the cipher C is acted upon by key K2 and the intermediate plain text T is generated as C minus K2 mod 26. Then this intermediate plain text T is acted upon by the key K1 and original plain text is obtained as T multiplied by K1 inverse mod 26. The relationship between the plain text and the ciphertext is shown in figure as ciphertext C is obtained as P into K1 plus K2 mod 26 and the plain text is obtained as C minus K2 into K1 inverse mod 26. Let us take an example to understand the Affine cipher. Let us generate the Affine cipher for the plain text hello with the key pair 7 and 2, that is the K1 is 7 and K2 is 2. The plain text hello is used character by character. The first character is H. If the characters are represented with the numbers from 0 to 25 with A as 0 and Z as 25, then H is represented by 7. Thus, Affine cipher for plain text character H is obtained as 7 multiplied by 7, that is the key K1, plus 2, that is the key K2 mod 26, which gives the value 25, which is the letter Z. Thus, the plain text H is converted to Affine cipher Z. Similarly, the plain text character E is converted to Affine cipher as 4 multiplied by 7 plus 2 mod 26, which gives the value 4, which is the character E. Similarly, character L, L and O are converted to B, B, W, making the plain text hello as Z, E, B, B, W as an Affine cipher. Now coming on to the polyalphabetic ciphers. In polyalphabetic substitution, each occurrence of a character may have a different substitute. The relationship between a character in the plain text to a character in the ciphertext is one to many. Playfair cipher is an example of the polyalphabetic cipher. Playfair cipher, also called as the Playfair square, is a cryptographic technique that is used for manual encryption of data. The Playfair cipher was used by the British Army in the World War I and by the Australians in the World War II. This is possible because Playfair is quite fast to use and does not demand any special equipment to be used. It was used to protect important but not very critical information, so that by the time the cryptanalyst break it, the value of the information was nullified anyway. The Playfair encryption scheme uses two main processes as shown in figure. Step 1 is the creation and population of matrix, and the step 2 is the encryption process. Let us take these steps in details. The step 1, creation and the population of matrix. In this, the Playfair cipher make use of 5 by 5 matrix, which is used to store a keyword or phrase that becomes the key for encryption and decryption. The way this is entered into the 5 by 5 matrix based on a simple rule. The first is enter the keyword in the matrix row wise from left to right and then top to bottom. Second step is drop duplicate letters. Step 3 is fill the remaining spaces in the matrix with the rest of the English alphabets A to Z that were not a part of our keyword. While doing so, combine I and J in the same cell of the table. In other words, if I or J is a part of the keyword, disregard both I and J while filling the remaining slots. For example, suppose that our keyword is Playfair example. Then the 5 by 5 matrix containing our keyword will look as shown in the figure. In the row 1, the first row of the matrix is simply the first 5 letters of our keyword, that is play F. None of the alphabet is a duplicate so far, therefore, we write these one after the other in the same row as per our rule number 1 defined earlier. The row 2, the first 4 letters of row 2 is a continuation of keyword IREX from where we had left in the previous row. This is as per our rule 1 defined earlier. However, after this we have a repetition of letter alphabet A as shown in figure. Therefore, we disregard the repeating alphabet A as per our rule 2 defined earlier and choose the next alphabet M. This gets loaded into the 5th cell of this row. The first 2 rows have covered all the alphabets of our keyword and nothing left to populate in our matrix from the keyword. Thus, from the row 3, we consider the rule 3 defined earlier. This rule suggests that we should fill the remaining part of the matrix with the alphabet from A to Z that are yet not used. Based on this criteria, we see that B, C, D, G and H will fit in the 3rd row of our matrix. Similarly, the 4th and 5th rows are filled using the rule 3 and we get K, N, O, Q, S in row 4 and T, U, V, W, Z in row 5. Step 2 is the encryption process. This process consists of 5 steps. The step 1 is before executing these steps, the plain text message that we want to encrypt need to be broken down into groups of 2 alphabets. For example, our message is my name is Atul. It becomes MY, NA, ME, IS, AT, UL. The encryption process works on this broken down message. Step 2 is if both alphabets are the same or only one is left on X after the first alphabet. Encrypt the new pair and continue. Step 3 is if both the alphabets in the pair appears in the same row of our matrix, replace them with the alphabets to their immediate right respectively. If the original pair is on the right side of the row, then the wrapping around the left side of the row happens. Step 4 is if both the alphabets in the pair appears in the same column of our matrix, replace them with the alphabet below them respectively. If the original pair is on the bottom side of the column, then wrapping around to the top side of the column happens. And the step 5 is if the alphabets are not in the same row or column, replace them with the alphabets in the same row respectively, but at the other pair of the corners of the rectangle defined by the original pair. The order is quite significant here. The first encrypted alphabet of the pair is the one that is present on the same row as the first plain text alphabet. The decryption process works in the opposite direction. We need to remove the extra X alphabet that we had added in the step 1 if any. Let us now take a concrete example to illustrate the process of encrypting text using the keyword. Our keyword is Playfair example and the original text is my name is Atul. We know that the matrix for our keyword is as discussed earlier. We have discussed this in detail earlier and need not to be repeated. Here is an explanation of the encryption process. Step 1 is, first we break the original text into pairs of 2 alphabet each. This means that our original text would now look like MY, NA, ME, IS, AT and UL. Now we apply our Playfair cipher algorithm to this text. The first pair of alphabet is MY. Looking at the matrix, we see that the alphabet M and Y do not occur in the same row or column. Therefore, we need to apply step 5 of our encryption process. This means that we need to replace this text with the text diagonally opposite to it. In this case, the text is XF, which is our first cipher text block. Step 3 is, our next text block is to be encrypted is NA. Again, step 5 will apply and we get our second block of cipher text as OL. We now take a look at the third block of plain text, which is ME. We can see that the alphabet E and M making up this block are in the same row, that is the second row. Therefore, based on our logic of step 3, the cipher text block is IX. We will take a look at the fourth block of the plain text, which is IS. We can see we need to apply the logic 5 of step 5 to get the diagonal alphabets. Based on this, the cipher text would be MK. We will now take the fifth block of plain text, which is AT. We can see that we need to apply logic 5 again to get the cipher text PV. Similarly, for the last block UL, we see that the two alphabet U and L are in the second column. Therefore, we need to apply the logic of step 4 to get the cipher alphabet LR. Thus, our plain text MY, NA, ME, IS, AT and UL becomes XF, OL, IX, MK, PV, LR. This is how the Playfair cipher works. In this lecture, we have discussed about the plain text, cipher text and also discussed about the 3 encryption techniques, namely Caesar cipher, Affine cipher and the Playfair cipher. In the next lecture, we will discuss the techniques Varnam cipher, Hill cipher, Vinegre cipher and the book cipher. Thank you.